polynomial functions. Recall that Pn of x equal an x raised to the power n plus an minus 1 xn minus 1 plus and so on to a1x plus a0 is said to be a polynomial of degree n if all the exponents are non-negative, and of course they are also not fractions. For instance, if we have a function f of x equal to 3x squared plus 2x plus 1, this will be a polynomial function of degree 2. If we have another function, say h of x equal to minus 6x cubed minus 3x squared plus 2x say plus 1, this again would be a polynomial function of degree 3. So we observe that for polynomial functions, the powers of x are either increasing or decreasing, as the case may be. But these powers of x are not going to be negative and also not fractions. So, how then do we find the limit of such functions? To evaluate limits of polynomial functions at any finite point a, we substitute or replace x with a. What are we saying? If we have limit of a function f of x as x tends to a, if we wish to evaluate this limit, we want to know as x gets very close to the number a, f of x gets very close to what? If we wish to evaluate this kind of function, where the function f of x is a polynomial function, what do? We simply replace x with the point a. So to evaluate this limit, we simply say f of a. And this is how it works for all polynomial functions. You substitute the point a into the function, and that will give us the limit of the function f of x as x tends to a. Let's take an example very quickly. If we wish to evaluate the limit, okay, as x tends to say 2 of the function 3x plus 2, we observe that the function here 3x plus 2 is a polynomial function of degree 1. So for that, how do we evaluate the limit? We simply substitute the point 2 into the function. So this limit will now give us 3 into x is now 2 plus 2. And this is 3 times 2, 6 plus 2 equal to 8. Hence, the limit of 3x plus 2 as x tends to 2 is 8. Meaning, as x gets very close to the number 2, 3x plus 2 gets very close to the number what? 8. Another example is if we wish to evaluate the limit as x tends to say minus 3 of the function x squared minus 2x plus 3. Again, the function x squared minus 2x plus 3 is a polynomial function, but this time of degree 2. So we substitute the point minus 3 into the function to get the limit. So this gives us minus 3 squared, because x is squared here, minus 2 into minus 3 plus 3. So minus 3 squared gives us 9. Minus 2 times minus 6, rather times minus 3 gives us plus 6 and then plus 3. So 9 plus 6 is 15. 15 plus 3 is 18. This implies that as x gets very close to minus 3, the function x squared minus 2x plus 3 gets very close to the point 18. At this point, we remark that for polynomial functions of this nature, the left-hand limit from the left, or what you call left-hand limit, is always equal to the right-hand limit. But this is not always the case for some other functions which are defined in a piecewise sense. So, to illustrate what happens in the piecewise sense, we shall consider the following function. We want to evaluate the limit as x tends to 2 of the function x squared minus 3 when x is greater than 2 and 2x minus 3 when x lies between 0 and 2. This function f of x is defined in a piecewise manner, in the sense that when x is greater than 2, the function is defined as this. And when x is less than or equal to 2 and greater than or equal to 0, the function f of x is defined as 2x minus 3. What we should take out of this is this. We are investigating the limit as x tends to 2. So when you say x is greater than 2, this means right hand limit. That's the right hand of 2. So when evaluating the right hand limit for this function, we shall use the function x squared minus 3. And when you say x is less than or equal to 2, that means you're looking at values that are on the left of the point 2. And this is what we're going to use to evaluate the left hand limit of this function. So let's proceed. So we start with the right hand limit. So right hand limit of this function. So we're looking at the limit as x tends to 2 from the right of the function f of x. So that will become limit as x tends to 2. Now on the right, x greater than 2 means right hand side of 2. The function f of x is defined as what? X squared minus 3. And this again is a polynomial function of degree 2. So to find the limit, we substitute the value 2 for x. So this becomes 2 squared minus 3. And that is 4 minus 3, which is equal to what? 1. For the left hand limit of this function f of x, we are trying to evaluate limit as x tends to 2 from the left side of the function f of x equal to limit as x tends to 2. F of x on the left of 2, we say x less than 2 or equal to 2. So x less than means on the left hand side of 2. So on the left hand side of 2, the function f of x is defined as what? 2x minus 3. And again, this is a polynomial function of degree 1. The limit of this function is 2 into 2 minus 3. And that gives you 4 minus 3 equal to 1. What do we observe here? We observe here that the limit as x tends to 2 from the right is the same of the function f of x is the same as the limit as x tends to 2 from the left of the function f of x. And what is the limit? The limit is what? 1. So the left hand limit and the right hand limit exist and they are the same and the value is 1. Since this happens, we conclude that the limit of the function f of x as x tends to 2 is equal to what? 1. Is equal to 1. So for a piecewise function defined this way, the limit of the function will only exist if the left hand limit exists, the right hand limit exists, and they are the same. If that happens, we now say that the limit of the function exists and the value is also 1. That is to say, if the left hand limit and right hand limit are not the same, it will imply that the limit of the function f of x will not exist. Let us take another example to see if we can clarify this point. Consider the example. Evaluate limit of the function h of x as x tends to 0. Now the function f of x again is a piecewise function. That means a function that is defined in 2 ways. In this case, 2 ways. It could be 3 ways or 4 or even more. So x squared minus 3x plus 3 when x is greater than 0. And what does this mean? If you say x greater than 0, That means to the right hand of 0. And 2x plus 3 when x is less than 0. So this means to the left hand of 0. So when we want to evaluate the left hand limit, we use the function 2x plus 3 because at that point x is less than 0. And to evaluate the right hand limit, we use the function x squared minus 3x plus 3 because at this point x is greater than 0. So let's proceed. This time we'll take the left hand limit first, LHL, I call it left hand limit. So we want to look at the limit as x tends to 0 from the left of the function f of x. And this means the limit as x tends to 0. Now on the left, f of x, okay, this is h of x rather. H of x is defined as what? We said x less than 0. So on the left of 0, h of x is 2x plus 3. And again, 2x plus 3 is a polynomial function of degree 1. So to find the limit, we substitute the value of x as what? 0. So we have 2 into 0 plus 3. And that gives us what? 3. So the left hand limit, the left hand side limit exists. And the value is what? 3. We now check for the right hand limit, RHL, right hand limit. So we're looking at the limit as x tends to 0 from the right of the function h of x. And that means the limit as x tends to 0, on the right hand side of 0, the function is defined as what? X greater than 0 is defined as x squared minus 3x plus 3. Again, a polynomial function of degree 2. So the limit becomes 0 squared minus 3 times 0 plus 3. And this gives us, again, 3. So we observe here that the left hand limit, x tends to 0 from the left of the function h of x, is equal to the right hand limit, x tends to 0 plus of h of x, and the value is 3. So since the left hand limit of the function h of x and the right hand limit of the function h of x exist and are the same, we conclude that the limit of the function h of x as x tends to 0 is equal to 3. As a last example, we want to evaluate limit of the function f of x as x tends to 3. F of x is again a piecewise function and is defined as x squared minus 3x plus 1 when x is less than 3 and 4 when x is greater than or equal to 3. Again, x is less than 3, that means on the left of 3. And here x is greater than or equal to 3 is on the right of 3. So the left hand limit as x tends to 3 on the left or from the left of the function f of x, that is equal to the limit as x tends to 3 to the left of 3, we have x less than 3. So the function is defined as x squared minus 3x plus 1. And again, this is a polynomial function. So the limit is given as 3 squared minus 3 into 3 plus 1. This is 9 minus 9 plus 1. And the answer is 1. So the left hand limit of this function, this piecewise function, as x tends to 3 is what? 1. That means on the left hand side, as x approaches 3, this function approaches what? 1. We now check also for the right hand limit. So the limit as x tends to 3 from the right of f of x is equal to limit as x tends to 3. On the right of 3, we said x is greater than 3. The function f of x is defined as 4, a constant function. So the limit of a constant function is just the constant function, 4. So we are saying that for this, on the right hand side of 3, as x approaches 3, the function itself f of x is just 4. So what do we observe here? We observe in this example that the left-hand limit as x tends to 3 from the left of the function f of x exists, but is not equal to the limit as x tends to 3 from the right of f of x. The left-hand limit is 1, the right-hand limit is 4. So the left and the right-hand limit both exist, but they are not the same. So what conclusion can we make from here? We conclude that the limit as x tends to 3 of the function given to us, of this function f of x, is equal to d n e. This stands for does not exist. So this tells us that if the left-hand limit of the function exists and the right-hand limit of the function also exists, as far as the two limits are not the same, it will imply that the limit of the function in question also, or the limit of the function in question, does not exist. Please do not fail to subscribe to this channel and like. Thank you.